problem 94 of Neetcode 150, Reconstruct flight path. This is a hard problem, but to be honest, you can do this in 10 lines of code. I think it is quite easy. So let's go ahead and read the problem. You are given a list of flight tickets. Okay, and within this list, at each index, we have from I into I. Okay, so we're gonna have a starting point and an ending point, right? Okay, we're gonna be given basically a position and an end that will be equal to 3 uppercase English letters, which is pretty much the standard to call an airport. Okay, we are being told that we're going to start from GFK all the time, so this is good, great to know. We have to return the lexicographically smallest path because there will be many possible paths. Okay. It is also possible that we do a back and forth from 2 airports. So it is possible that that we go to GFK to Seattle, and we go back to GFK to Houston, and Houston to GFK. So this is another path. And when they say like lexicographically smallest path, is basically that, see, we could go from GFK to Houston, and then to Houston to Seattle, then to Seattle to GFK. You can also start from GFK and initially go to Seattle. But if you take the first letter in the alphabet, H comes before S. So this is what they mean basically when they ask for the smallest one. Okay, so that's that's pretty much the entire concept. I think that the solution will be quite simple once we'll start coding this. So what I will do is that I will first create a hash map, and I will store basically the place, the source destination, and also the target destination. That's what I'm going to do in there. I'm also going to be willing to actually uh, add them um, in the lexicographically smallest place. So what I will first do is that I will basically just sort the tickets that were given here. So if you just sort this, it's basically going to give you Houston before Seattle. So this is exactly what we want. And after this, I will call a def for search function. And what I will do is that I will pop through all the destinations for a particular source, and I will just basically uh, take that destination and call a def for search upon this one. So let's go ahead and do this. So first of all, we have let's say we have our trips, and this is going to be my default dict or my hash map. All right, and basically I want the values to be a list because one place might have many destinations. For example, JFK here has Houston and Seattle, so we want to go see both places. So that's why we have a list. And what I will do is that I will say for source and destination and thickets. But recall that we don't only want to have any order, we want to have the lexicographically smallest one. So I will sort them. All right. And also one thing to notice is that when they are sorted, technically the lexicographically smallest value, so the value of the first letter that appears the first in the alphabet will be like the first added to our default dict. But the way that we're going to retrieve this value in our def for search is by using a pop. So we're going to pop this, meaning that we want basically to have like a reverse order. So what I will do is that I will just reverse this like that. So that now like the first letters appearing in the alphabet will be towards the right, so we can pop them. Cool. So now we're gonna retrieve the source in the destinations and tickets in a sorted way. And what I will do is that I will just add them to trips, so our hash map. All right, so pretty good. We have our hash map now with our source and our destination in the lexicographically way we want it to be. And now we can actually have this thing here, the output, which will all the path of the trip. And now we have our depth first search function. So we're just gonna call this like that, and we're gonna pass a source to it. And what we want to do in this source is basically we want to go see all its destinations. So initially we're going to have GFK. So GFK here on this example to the left can go to Seattle and Houston. So what I will do is that I will just say while there are destinations, so while trips at SRC, while there is something, I'll call it destination, and I will set this equal to the value that we pop, which is the smallest lexicographically value. So it's going to be trips at the source, and I want to pop this just like that. And now I can call the first search function on that destination. All right, and once this is done, I can actually add to the output. I can add the source we started from. And actually that's everything, right? Because the this depth first search function itself is quite simple. We just want to go see all the places starting from JFK. And the good thing is that we don't have to wonder about like which place we're starting from. We know we're starting from JFK, so we can call depth first search on JFK. And we know that from there, we're just going to go see inside the hash map we created. We're going to go see all the places we can go from GFK. And we're just going to pop the values, which will be the lexicographically smallest one. And we're going to do a depth first search on it. And we're also going to do a depth first search on the second one, which is going to be Seattle. And from Houston and Seattle, we're also going to search the places we can go from, which will turn out to be GFK itself. And that's basically the two calls we're going to do from the initial GFKs in the example we have here. And once these two calls are done, we're just going to add to the output GFK. So that's it. Now we can return the output, but not yet, because we are adding at the end of a loop. So it means that our output list is going to be reversed, because at the really end of our depth first search call, when we hit like this last branch, then we're going to start adding the sources to the output, meaning that it will actually gives us an output that has a reverse order of the path we have. So the output will have to be reversed like this. And now we're good to go. We can test this out. And we have an array, of course. Anything else? This works. Awesome. So this is the algorithm. Quite efficient. I hope you learned from this video. And also I will conclude on the time complexity. Basically, we are seeing once through all the neighbors inside our depth first search function. So the depth first search itself is going to have a time complexity of big O of E, where E is basically the number of hedges that we have. And basically the longest thing we have in our code is here when we sort. So sorting itself has a time complexity of E log E. So this is the time complexity that will be dominant in our code. So the time complexity of the entire algorithm is e log e. And in terms of space complexity, all we are creating is a hash map. So creating a hash map itself, where one destination is related to its source, that's going to be um, the big O of E. All right. So thank you for watching, and I hope to see you in the next one.